Hi friends, we are live, we are back. I'm Andrew, this is Code Gets Creative, and on this channel we do all sorts of creative coding. Today we're going to do something a little different. We've been talking about this for a while, but we're finally going to actually do it. Today we're streaming Screeps, which is an online, it's a game, but it's a game that you play by programming. And for you gamers out there, it is an MMO real-time strategy game, which is bizarre in and of itself. But the way it works is you control your little empire of Screeps, and you tell each of them what to do by programming. And your code gets run on a server along with everybody else's code. And every tick of the game, which is about every 3 seconds in the world, everybody's code runs. And we find out what happens. So, should be cool. I have been playing this for a while now. I got really into it about 3 years ago. Wrote quite a bit of code for it. It was really fun. And then kind of, I don't know, got interested in other projects, focused on those. Came back to Screeps recently, a few months ago. I think it was like 3 or 4 months ago. And this was after like changing jobs and learning a lot of new stuff about like asynchronous event-based programming and things like RabbitMQ and Kafka, and all sorts of other just kind of general like exposure to good practices in software engineering. And so coming back to it, it was really fun because I was able to improve quite a bit on what I already had. So I think we're ready to do it again today. The goal that I have, longer term, gradually working on this thing, is I want my little Screeps empire to just run itself. I want to be able to start it somewhere, and it should just start growing all by itself like a little ant colony and just do its thing. So that's the idea. Okay, we should just get started. Like, this is gonna be fun. Let me switch over to here. Maybe I'll like do this real fast. For those of you that are not familiar with it, yeah, here's Screeps.com, MMO sandbox game for programmers. And you can read all about it. It's really cool. Yeah, we're going to do Screeps World as opposed to Screeps Arena. Arena is like a new kind of like split off of the same game, but with a lot of the same ideas. Yeah, let's look at some of these. This is what gameplay looks like. So you can see how, like in this image, we have a snapshot inside of what's called a room, and each of these little Roomba-looking things is a creep, or sometimes I'll just call them Screeps. And each of them is doing tasks. So like these three up here are harvesting this energy source, and then they end up storing them here or here or here or here, and then other Screeps can pick up where they left off and grab the energy and use it to upgrade their room controller so that they can move up the tech tree and build new buildings and do more powerful things, or create new structures, right? Like each of these little line segments is a road, which allows Screeps to move quicker, and sometimes pass over difficult terrain like this green swamp, or even like you can pass over walls. And yeah, stuff like that. It gets crazier because, let's see. I mean, you've got the idea of like defenses. Looks like these are just about to be nuked. That's crazy. And then here's an attack that's happening. So a player is attacking an NPC, like just AI stronghold right here, and is like working its way into the center. And let's see. Here's an example of like kind of a super base, you know, with all of these like defenses built around the perimeter. And I mean, this kind of looks like the aftermath of a fight. So yeah, Screeps Warfare Championship, kind of cool. So that's the general idea. Look for this kind of stuff. No, we don't want to go here. Here's the API documentation. So I mean, you'll notice that this looks like the docs for any other kind of code that you might write. You know, these are getters and setters and function calls, and you can see examples of how to call stuff. So it is very much code. You know, you play by coding. So now let's actually play it by coding it. Here's my code, by the way. We're gonna do a deep dive on this real soon. Okay, here's the game. They're different. So this is like a single giant open world. We're on shard 2. I think there's 4 different shards. I played my last like 2 or 3 rounds on shard 2. Shard 2 is great. So we can choose that again, and we get to choose a room. So it's kind of like defaulted to this first area, and we can scroll around and look at all this. There are a couple of like very large players in this zone. You can see that it's sort of this like square region, right? This guy's kind of powerful. This guy's kind of powerful. This guy's really powerful. The night is dark and full of terrors. Zephyr. That's pretty sweet. Okay. So I don't know about this zone. Let's look at another area. Okay, this is quite a bit more sparse. Ooh. Maybe not. We got this super duper powerful player. And this other super powerful player. Okay. I think we could like try this one just because this side of it is kind of sparse. Looks like this player. Oh, Overmind. Looks like this player. You can see little red dots because this player is kind of moving into these unclaimed rooms, but is starting to harvest out of it. So we might want to kind of steer clear of that as well. Oh, this player is harvesting out of this room, I think. So this room is kind of spread out, but honestly, it might work. Let's check it out. So this is a room controller. This is where we have to pump energy into it to upgrade and get stronger. We've got 2 energy sources. You want to look for a place with 2. This is another mineral that you can mine. That's kind of later game. I'm not really there yet, to be honest. So I'm going to kind of ignore that. But I think we could set up like right around here and then focus on this, upgrade here, over here when we need. I think we should do that. Let's do it. As a matter of fact, I think we might set up like around here-ish, because then we're kind of equidistant between these 2 energy sources. And like bit more time to travel up to here, but that's kind of secondary to like just pumping out as much energy from these as we can. Let's do that. I'm gonna place it like right here-ish. Let's see. Yeah. Call it spawn 1. Cool. All right. So we've started. Oh yeah, so I actually think there's a bug in Screeps where it double logs everything until you leave and come back for the first time. So I think now it's not going to double log. Okay. Cool. It just ran a big chunk of my code that is looking at these structures. These are all constructed walls. So I think like we're moving into some place that a player used to own because they built all this. It's kind of nice like inheriting it. You'll notice there's a bunch of other stuff going on in the logs. That's all running from my code. We've got this idea of directives, and I think this is where we're going to pick up today as well, is like working on directives. And this directive is already completed. Great. So notice how we just spawned this creep right here. It's doing its thing. Let's go look at the code. Yeah, this should be an upgrader. So if I go over to my code, let's see, main.ts. This is the entry point of everything. I'm writing my my Screeps bot in TypeScript. You can also write it in plain JavaScript. So you can see a bunch of stuff here. Notice how there's this function called loop that gets exported. This is kind of the entry point into everything. So this is a pretty short function, relatively speaking, but it's really just delegating to a bunch of others. So like, tell all my creeps what to do, tell the room what to do. So the room is actually an entity that thinks for itself. Run towers. Towers can like defend or repair stuff. And they can attack enemies. All this kind of stuff. There's even like I've baked in logic for like collecting stats so I can see how we're doing over time. But let's see. What is it? It's like debug roles? Yeah. So I've got this commands.ts. This is a really convenient like kind of set of functions that are available in the console and that I've written these in. We can say creep.debug roles true. And so if I come over here, creep.debug roles true, run that. And now this guy, every single tick of the game, he's going to say his role. Harvester. There we go. So that's kind of cool. We'll gradually get more and more. I'm surprised actually that that's a harvester. Oh, I know why. It's because he's an emergency harvester. Notice also we've got a bunch of flags that have been placed here. One of the directives is to plan out a base. And so the construction of a bunch of stuff here is automated. So it's a building plan, road, and then random number. This is all going to be roads. This is going to be a tower. This is going to be a storage. This is going to be another tower that we'll get to much later. Okay, that's the idea there. Notice meanwhile that my spawn is very slowly incrementing in its energy. So every tick, it adds just one more. And eventually this harvester, it's going to get 50 energy from this energy source and it's going to deposit it into here. And so we'll eventually fill this up and then we'll be ready to automatically spawn another creep. So that'll be great. But, and I'm not surprised that we're getting to this point. It's going to be kind of slow going if we just wait for all this to happen here. So Screeps actually has this cool feature where you can jump into a simulation that just runs locally on your computer, and the tick rate is much, much faster. And so it's a lot easier to tweak your code and debug it in isolation and then run it again in the open world. So let's go ahead and do this. It'll boot up for a minute. Here we go. So this customize button is unique to this simulator. So let's say, let's see, we need some energy sources. I'll put it like here and here. And then my spawn, I'm going to put right in the middle. We'll call it spawn 1. Okay. And now that that has happened, you'll notice everything kind of starts up. That's cool. Notice also that it's pretty fast, 1 tick per second. We can even bump that up. Yeah, 5 ticks per second is nice and fast. Here goes our harvester. And now, yeah, we've just planned our base. And let's see, we are switching over. Let's close this. This is the streaming music. I've got my code running. What this is doing here is it's running Webpack, and so every time I make a change to my code, boom, it's going to synchronize it to the Screeps server, essentially. If I remember correctly, I actually need to switch my environment. I'm not going to show this part on screen. Oh no, just kidding. I think there's a way to change the settings in the game so that it's pointing to that. We go to here. There we go. Let's just prove that this is working. So I'll go to main.ts and I'll just say console.log, we made an edit. Save that. We made an edit. Sweet. So that has synchronized our code to the simulation room. Okay, cool. So now we can do that same thing, like creep.debug roles true. So we can see who everybody is. They're all doing their thing. As they get started, I want to look at directives. So, and we're gonna close a bunch of stuff here, which we will later reopen immediately. So, yeah, let's look at some of this logic. We've got creeps, and we're running their roles. And then we've also got rooms, and we're running their roles. Let's look at creep roles. You'll notice that this is written as a big lookup map, where the name, you know, the machine readable slug or name of a role type is on the left, and then we've got an object that it points to, basically a class. And so if we dig into that, that looks like this. Remember that we have harvesters, right? Yeah, here's a harvester right now. So we can get its role name, it is harvester. We can, when we go to spawn a brand new one, we can choose what body parts it should have. Like the way that this works is, if I can click on it, each of these little circles represents body parts that have different functions. So this can move, work, and carry. So that's what this is about. Based on kind of energy capacity that's in the room, we're going to choose more advanced configurations for these. That's that. And then here's run. So run is going to get executed every tick for every creep. So we pass in the creep. We have a reference to that. And then notice how we have this state machine. It knows how to initialize itself. So this is its initial memory context. And then it has states. And so it's in a harvesting state or a storing state. It starts in a harvesting state. So notice how within that, when we tick, we say, hey, if we don't already have an assigned source ID, then go ahead and assign one. And then we say, hey, if you're already holding as much energy as you can possibly hold, then actually transition into the storing state. But if all that is good, we're going to go ahead and do this. We're going to say, like, either we're in the room that we want to go into, or we need to travel there. And once we're in there, we're going to harvest. So we still haven't gone all the way into, like, native functions that are part of the Screeps docs yet, right? We're starting to get there though. So here's action.harvest, and notice how we call creep.harvest target. So we can actually find that here. Harvest energy from the source or resources yeah, energy from the source or resources from minerals and deposits. Cool. So that's what that looks like. And it can like return okay, or it can return different error codes that we can account for. So that's the idea there. Okay. So we've looked at creeps, you know, just at a really high level. Now let's look at rooms though, because directives live inside there. So notice that we have kind of a similar setup. We've got like a lookup of roles. We have an explored room and a home room. And basically, if you have a spawn, then that's a home room. So we are role home. And if we go into that, notice how this looks kind of similar. We have a run function that takes in the room as a parameter, and then we can do some stuff. Notice how we might auto spawn from it. So notice how right here we're saying like, hey, take the number of ticks, mod 10. If that equals 0, then do this. If mod 10 is 2, then do this, mod 4, mod 7. So this is kind of like a performance enhancement here where we're saying only run this every 10 ticks. And run this every 10 ticks, but like offset from the other one. That's the idea there. And you can see we've got processing events and processing directives, and these two are related to each other. So an event, the idea here, we're talking like the kind of model of my program, right? My Screeps bot. But the way that mine works today is an event is something that occurs like in the outside world that we observe. An event happens. So for example, notice how we keep track of the, let's see, role home memory.rcl. So this is the room controller level, and right now it is level 1. And so what this is saying is if the new RCL is greater than the previous one, then we've upgraded, and that is now an event that has occurred. So as a result of that, we actually enqueue some directives. You notice how we do that by looking up in a map, RCL events to directives. And then for each of those, we push that into an array of pending directives that belong to this room. And then we log it. So here's that lookup map right here. So the way that we read this in plain English is we say, when the room has been upgraded from 0 to 1, meaning not owned to owned, then we should do these directives. Like we should enqueue these directives to be processed later. And then when we hit RCL2, we should do this, etc., etc. Notice how there's a bunch of kind of comments and stuff that's not actually implemented here. So that's what we're doing today, is we want to build out some of this stuff. And all of these three, they're implemented, and we've already seen them happen actually. So set creep requirements. Notice how we basically say like, hey, the room needs to always have this and this and this and this. That's what this is doing. So auto spawn takes care of that logic. And then eventually we're going to have a more advanced set of requirements. Notice how we introduce the idea of a repairer and a manager kind of stuff. Cool. So that's that. We wait for spawn. This is a simulation specific thing where it's like you haven't actually set down the spawn point. So just wait for that. And then plan base, that's the thing that actually sets down these flags. Now plan base doesn't actually start constructing them, but it plans where they will be. Something important just happened. This just went from RCL1 to RCL2. So notice how, we have upgraded the room to RCL2. We got a new directive. This happened a couple ticks later. Build extensions. So now it's time to process those. So here it is, right? We grabbed that. We enqueued that directive based on the event. And then we went ahead and started processing it. Notice how we've added these new things to our base. This is a construction site for an extension. So we need to pump energy into each of these to build these extensions, which let us store more energy and build more powerful creeps. This guy's a builder. You can see him shooting energy into it. 65, 70, 75, 80, etc. We got 2 working on it now, so it'll go faster. Okay, so and what is this said? It already thinks the directive is complete, which is not really accurate. I can't remember if I've changed that logic yet, but let's look at how we process directives. Let's see, we take a directive, we initialize it if it's brand new, we can check its completion, and then this is all unrelated. Okay, but notice how we've got this directive module. Oh, let's bring that back. Right, okay, so roll.home is processing directives, which is calling into here. Cool. Notice how, surprise, surprise, we've got this other lookup map, right? There's a lot of need for polymorphic type behavior in Screeps, because you end up needing to be able to kind of switch out these types of implementations. So build extensions, we just saw that happen, right? Notice how that's stored here. This code calls this code, calls this code. So build extensions is of type directive runner. So if you want to introduce a directive, you need to implement a runner for it, which has an initialize function and an isComplete function. That's that. And so let's check this out. Initialize is pretty fancy. Notice how it might not look like there's a lot of rhyme or reason to the placement right now, but essentially what it's doing is it's placing everything in a checkerboard pattern. So you could imagine, let's see, if you look at coordinates, like I'm hovered over this right now, x equals 15, y equals 21, so they're both odd. If I move over to here, this is 14 and 21, so one's even, one's odd. So you can imagine, like on a checkerboard, these are the black tiles and these are the white tiles, or black and red, depending on your version of checkers, whatever. So they're placed according to that. You choose the checkerboard and you do it away from this base that's been planned. So notice how none of these have been placed inside of this area that's been flagged off, but they've also been placed as close as possible to the spawn, given those other constraints. And it also takes into consideration like walls that are there and stuff like that. So it won't attempt to place it in a spot that's unplaceable. That's cool. They're doing their thing. Looks like this is a quarter of the way done. So being able to speed this up is really important. But let's look at is complete. What are we saying here? Extensions in progress. We find my construction sites where the structure type is extension, and we say that should equal 0. Interesting. So let's try just evaluating that. So I should be able to say room dot first. This is a function I wrote, but we have a reference to the sim room, and then we can say can't remember. Let's do this really quick. So we've printed out the full contents of our memory as JSON. We can zoom out a little bit. So yeah, like the room's role is home, etc. It's got a bunch of history, role, home, directives, and it thinks that nothing is pending and nothing is in progress. So that's that. Oh, that's right, though. What we actually want to do is we want to call a Screeps API. So room is that reference. So let's actually, we can basically just grab this. Room.first .find according to this filter. So look at that. There returns all 5. So my guess is that what happened is is that like this actually gets run on the same tick as this, which means that we've placed construction sites, but Screeps hasn't actually registered them yet, and so this probably does actually return 0 because it's not going to find those yet. Huh. How are we going to deal with that? I think one way that we, probably the right way to deal with this is we say something like, context dot initialized equals false, or like registered maybe. And then we say like, if we're not registered, then return false. But then immediately after, context.registered equals true. So you can kind of see the idea that like we've baked in this concept of being registered, and so we know for sure that we're not gonna execute this too soon. I don't know. That feels a little bit ugly. We're gonna like rerun this every single time we check. The other thing is I think we're gonna have other directives that need this concept. So maybe what that means is that directive runners should introduce this idea of like waiting or not. So maybe it's like wait to register. And that returns a Boolean. And I think I like this approach more because now we can reuse this for a lot of different directives. I don't like its name though. Let's see if we can come up with a better one. Wait to register. Maybe it's like delay progress check. Delay completeness check, probably. I think I like that. So yeah, let's add that. And yeah, that's cool. We can put that in there. And we don't need all this stuff that we added. I'm going to save this. And this is true. Oh, hey, that doesn't have to be a function that returns true. That can just be true. Let's put that up here. Yeah, so I like this. Now it's just static configuration that lives on the runner. Save that. We have broken all of our other directive runners. So let's go in and add those. Build buffer has not been translated yet. Plan base. Notice how it needs it. Put in that. Wait for spawn. Wait. This one probably the word wait threw me off. Like wait is the same as delaying. Yeah, if we're not in the sim room, I want this to complete immediately. That should be good. Close some of this other stuff. So let's see. Got a directive. So let's see, we initialize a directive and save its context into there. And then if there's anything in progress, or no, there can only be one in progress at a time. We check the directive completion. Mark end tick, yeah. So what I'm thinking here, we have a start tick, and I think that'll be a really easy way to implement that delay. We go into here. Get the directive runner. Yeah, it's right here. Oh, whoops, I've already got it open. We could say if directive runner dot delay. So if delay is true and game dot time is equal to the context start tick, then we're going to return false. And we should log this as well. Delaying completeness check. Yeah, that looks good. Cool. So now we need to simulate this again. So there's a cool thing that we can do. Yeah, notice how we're almost, yeah, we're over halfway, but it's kind of slow going in the early game. It's kind of slow going like in general, to be honest. Like Screeps is just kind of a slow paced game. It's about like making this work over the course of hours and days, and because this thing's gonna keep running, not in the sim room, but like in the shared world. Like it's just gonna keep running all day and all night, even if I'm not logged into it. Yeah, that's kind of the trade-off. So okay, let's actually start a new sim room. We'll jump back into here. Got a room. Storage. Oh, whoops. I want a source. Let's destroy that. And then spawn. There we go. And let's speed this up a bunch. So notice how we've set requirements, we waited for spawn, we planned the base. So now all we have to do is wait for this to hit RCL2. But the cool thing is we can actually just click this button and it will happen for us. Let's go ahead and do that. Boom, we're at RCL2. And this will figure out that there should be a new directive. There we go. Yeah, delaying completeness check until next time. Yep, and notice how we're just going to keep checking over and over and over. Yeah, as a matter of fact, we had a storage and then deleted it, right? But let's say we bring that back actually. That will dramatically speed up the amount of time to build this stuff. And then we can see that build extensions, directive finish. That should be cool. It's just going to keep, dutifully checking for that. So, yeah, I think that's going to be a really noisy log. So let's actually take it out. Like we know that's going to work, and I think we don't particularly need this. I'll leave it floating around as a comment for now. You'll notice that in order to check whether it's completed, no, sorry, I want to look at build extensions. So its implementation for is complete is like, oops, is like find the construction sites that are an extension, make sure they're 0. So eventually, these should all, be finished, and they will no longer be construction sites. They'll actually be extensions. But there is a hack way to kind of work around that if we want. We could just like delete them all, and then that'll end up returning true on that directive. I wonder. I'm gonna run debug roles. So far, we just have those roles. We don't have any builders. What's here, by the way? Tons of stuff. It is a ruin. Kind of cool. But yeah, we will get caught up. Oh, those are all doing it. We need a manager is what we need. No. We'd say spawn. I can't even remember what it is. Can I do that? No. Spawn.spawn1. Yeah, okay. That's the thing. Alternatively, we can just do like this harvester. So we can say game.creeps that name memory.role equals manager. So there, we just hacked that. What it's going to do now, the way that the manager role works, its whole job is to take stuff out of storage and fill up the shorter term stuff, like the spawn. And it's going to do that as fast as it can. And we've got all of this storage saved up right here. It'll be able to do this really fast. And that means that we will be able to just pump out builders and go a lot faster. Boom, there we go. So I like the manager role. People call it different things. Like I've seen hauler, I've seen queen, you know, kind of like a queen bee that like moves honey between different open cells in the hive. There we go. Deposit that. It just started a builder. Yep. Cool. Okay, so that's doing its thing. I think we can let it keep doing its thing, and we can start thinking about the next, what's it called? The next directive to build. So we say, when we hit RCL2, we build extensions. Yeah, and then the next thing we want to do is build buffers. I'm excited about building buffers. What that means is, you can see we've got an energy source here, energy source here. Oftentimes, your energy sources are like pretty far away from your base. And so you have to kind of travel to get there, and you waste a lot of time moving back and forth. So the idea of a buffer is basically a container, which is like a small storage thing that you put just a few, like 1 or 2 squares away from the energy source, and then as you harvest from it, you just drop it straight into there, and the managers go and pick it up. And yeah, once we get to RCL2, we're in a more stable state. Like each of these should be complete. And so we'll be able to build like bigger and more powerful creeps at that point. So let's do it. Let's build some buffers. In order to do that, we need to wire it up here. And you'll notice I used to have this other one, right, called build buffer. So I'm going to remove, well here, we can, this doesn't exist just yet, but let's take this and change it. This is a kind of previous iteration of the idea of directives in my code. So notice how build buffer is just a raw function. There's not any concept of like a directive runner or whatever. It's just like execute this code. But I've already figured out some of this stuff in terms of placement, and that was some of the hard stuff. So what we're going to do is we're going to grab this and rewrite it in this new style. So I don't need to import, or I don't need to export that anymore. I say const build buffers, which is of type directive runner. Also, this is kind of silly, but I like single quotes. If you're familiar with a tool called Prettier, if I had Prettier wired up, then this wouldn't matter, but whatever, I don't. Someday I'll get to it. So we define that, we'll have to add the functions into it. Yeah, and then we just export that as the default export. Okay. So we need to initialize. Oh, hey, and I also need, whoops. I also need this, and as a matter of fact, this also needs to be delayed. That should be good. We're gonna initialize, and then we're gonna check if it's complete. And we'll say false for now. Okay. What's this complaining about? Oh, yes. This is the default export. We changed that. So, okay, that exports now. We need to implement all this stuff, right? So this is just dead code. But yeah, we're ready to initialize this guy. So let's pseudocode this out a little bit. Honestly, I think we're gonna end up keeping all of this. Like, we're just gonna call this function twice. So I think we say for each buffer in the room, call build buffer. And let's see. So at the end, we create a construction site. Okay. So I think we need to figure out how to call that. We can say room first dot find, and I think it's find sources. There they are. So if we look at these IDs, one ends in 320, one ends in 93. So here's 93 in this tiny text. Hopefully you can see it. And then this other one is 320. By the way, the ruin decayed. So we've got this like enormous amount of energy on the ground. Pretty funny. How are our builders doing? Yeah, look at this is going so much faster than before. Now that we've got our cheat code storage tank, we're slowly draining that out. So that's cool. And we're also still dutifully upgrading the room controller. So yeah, let's see if we can get build buffers like implemented in time. Honestly, like it's gonna be so similar to this. Let's just copy and paste some stuff. Yeah, really, it's just that. We're gonna say room.find sources. And then we'll say for source of sources. Build buffer with the room and the source.id. That's it. That's it, my dudes. That's cool. Is complete. Now, and I'm gonna cut a corner here. What I'm gonna do, I'm gonna make the assumption that you don't like, if you're building buffers, you're not gonna have any other containers that are in progress. So I'm gonna say buffers in progress. So this should be container and that number should be 0. Yeah. Save that. And they're all still doing their thing. This is getting kind of noisy, so I'm going to turn this off. Okay, but yeah, look at that. It's just about finished. Boom. That extension is now live. Notice how we can store energy inside of it. That's going to help us build creeps faster and build bigger ones. That's cool. And they've started working on the second one. So let's do this. We should dump a bunch of, or no, we need to manually add the directive. Oops. Roll home. Yeah, that's the thing. So pending should exist. Oh, pending is empty. Yeah. So I want to say pending.push, and then we're going to grab this. There we go. And if we look at in progress, yeah, it's an object. Great. Yeah, you can see how this is the directive progress context for this one. So we're building extensions. Here's just when we started doing it. We came up with an ID for it. And we're still checking, right? Every 10 ticks, we're checking to see whether it's complete or not. So I'm gonna cheat a little bit. I'm gonna remove these other sites. We don't have to wait quite as long. But as soon as this finishes, it's going to realize that that is complete. Making good progress. And then once the buffers are built, we can set the creep requirements to the more advanced one, which will be cool. Getting really close. $800, 2,900. Okay, here we go. Here we go. So we've completed that. It checked to see if this new structure is a buffer. That's some other code that says, hey, is this container a buffer? Okay, but eventually we should come around and say, oh, hey, there's a new pending directive that we can pick up and start working on. Wait a minute. Oh, I missed one. Okay, yeah, I'm gonna go ahead and delete this one. Boom. Okay. Directive is complete. So now 10 ticks later, as soon as that happens, yeah, we pick this up, build buffers. Ah. Oh no, look at this. We've planned out our two buffers. I don't like their placement because they both happen to be like as far as possible from the spawn. the logic for these, if we walk through this, is what am I looking at? I want this over here. There we go. Okay. So the logic for this, when we say build buffer, we get real fancy, right? About saying, like, what does the terrain look like? And then we say, like, where are some places that you can stand next to the sources? So all of the possible buffer positions, we have to prune out a bunch of stuff. That's what happens there. Possible buffer positions. In the end, we've got a bunch of possibilities. And in this case, it's like, you know, all the way around here. Everything that's 2 squares away. But then notice how we sort by neat alignment. And this is what's killing us right now. Sort by neat alignment basically says, I would love it if, yeah, there's a target position and then position A, position B. And so A might be neat and B might be neat, which is where something is neat if their X values are the same or their Y values are the same. And so these are both considered neat because they line up nicely. It's not on a diagonal. It's not like right here or here. So it looks a little more visually appealing. But what we need to do is, you know, we need to say sort by distance from spawn, then neat alignment. Or maybe it's not even that. It's like, we need to say distance from spawn and neat alignment. Let's think about that for a minute. Because I would love to have neat alignment. I would even sacrifice a square or two of like inefficiency for neat alignment. Okay, so that should work great. Here's what I have in mind. Basically, sort by neat alignment, then distance from spawn. Yeah. Okay, so we're gonna write a cool function right here. We are gonna create something called, we're gonna call this compose sorters. And this is gonna be, it's a function, but it's actually like, let's see, we need to make a type for this. Sorter function. And this is equal to and this returns a number. So that is a sorter function of type T. Yeah, I wonder. Oh, let's see. No. I do actually want them all to be the same type. So this is a sorter function for room position. And so this function is going to take in sorters, and then it's actually going to return. Ah! This should also be generic. Yes, it should. And let's see, I have to add this here too. And And then what we'll do is we'll say position sorter is compose sorters, where we are going to pass in sort by neat alignment, followed by sort by position, sort by, I want to say like sort by distance to, something like that. And then I want to say like spawn.position. And then, oh, okay, so sort by need alignment needs to pass in that. Yeah, and I know we've put squiggles all over the place, but we're kind of like painting out what we want this to be, and then we'll fill this in. Okay, so we need the spawn. So this is going to be find my spawns at 0. You can have multiple spawns. I'm not going to worry about writing for that just yet. I think this should be fine. If we've got like a beautiful fully automated base at which like this becomes a problem, then I will be thrilled. So we have our spawn. So spawn.pose exists. So now we need that. I have this. Okay, closest. It's kind of a weird function. We have to do a Pathfinder search. Ooh, okay, so this should be like sort by travel distance or something like that. So I'm going to pass in target position. And notice here how I'm doing currying. So this is a function that returns a function with some new parameters. So, we've got a lot of things shouting at us right now. Eventually we want to pass this in. Sort by need alignment and distance from spawn. Cool. I'm puzzled why do we check for the length after we attempt to sort? I actually want this like right here. So we basically say like, find the positions If there are no possible positions, then throw, and then sort. So we're picking the very best position. Select that one. It's going to be the first one, and then create a construction site there. By the way, how are things looking up here? We're making slow, painful process on that. Progress. That word. Okay. Yeah, okay, so let's implement this compose first. So how would we do this? We'd say like, try the first sorter. If it returns 0, try the second sorter, etc. Yeah. So I think what that basically means is oh, okay, we need to and that's, yeah, okay, that's what that's complaining about. So we're gonna say item A, which is of type T, item B, which is of type T, and then we're going to say for each sorter, we're going to pass in item A, item B, and then we're going to say if sort result is not equal to 0, then we're going to return that sort result. Yeah. So in other words, like, okay, try sorter number 1, right? Call that, take its result. If it's not equal to 0, that means that we know from that very first sorter, that like top priority sorter, that the two items are different in priority. Or different in sort value, and so return that. And if that happens to be 0, then like, okay, by this first thing, there's nothing different about them. But then we should, boom, go on to the second one and see if there's anything different there. So that's what that does. And eventually, if we work through this entire list and we haven't returned by now, then boom, we'll return 0. As far as we can tell, you know, all the sorters said they were equal, so they're equal. So, cool. That is our compose sorters function. It's a pretty nifty utility, if you ask me. Okay, so now we need to implement this travel distance thing. Let's see. The squiggles to go away for a minute. So I think we need to say calc distance from A to target and from B to target, and then subtract. Yeah. And I can't remember which one we subtract. So we're going to head over to sort on MDN. Always forget. Here we go. If it's a positive number, B comes first. If it's a negative number, A comes first. So negative A comes first. So let's see. If B is a big number, A is a small number, B minus A, that gives us a negative number. So A comes first, yeah. No, B minus A, right? Big minus small. No, small minus big. A is a small distance, B is a large distance. Small minus large is a negative number, A comes first. Okay, whew. Okay, so let's figure out this this like Pathfinder thing. And let's actually look in the Screeps docs for this. Pathfinder. Is that? I don't know if that's what I want. Oh, here it is. Okay, Pathfinder does search. So the origin is a room position, and then the goal, a goal or an array of goals. It's kind of cool. So let's say distance A is equal to pathfinder.search from position A to the target. And yeah, we should have some kind of a range, right? So let's see. Range to position before goal is considered reached. The default is 0. Please note that if your goal is not walkable, for instance a source, then you should set range to at least 1, or else you will waste many CPU cycles searching for a target that you can't walk on. Oh, and that is true. Like our thing is not walkable. Because you can't walk directly onto a spawn. So, okay. I think that means we need to pass that in. Oh, option is... Oh, whoops. So goals is actually... position range. There, that should look like that. Okay, so are there any options? Neat. Okay, yeah, we don't need any of this stuff in our case. So we got distance A, distance B, And then I figured this one out, you guys. It's distance A minus distance B. What is... Oh. Oh, that returns a Pathfinder path. Well, what's that? An array of room position objects. Okay. Yeah, oh really? It's cost that we care about. And I would assume if we get incomplete, then cost is probably infinity. Yeah, I like that. There is probably an opportunity for memoization here. This is going to be a little bit expensive to call over and over and over for a lot of things. Because remember that... Oh, look there. Chugging away. We're going to be calling this for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? Different squares. And we're going to keep calling that in like a bubble sort style, I believe. So that might be expensive. Well, let's write it this way for now, and then if it like super duper spikes our CPU up here, and it's like wasting all of our time, then we can start to get clever about it. But I think this implementation should work. Like it's correct. And it should be 1. Cool. So, all right, we need to test this. Yeah, ironically, we've gotten this far, which is, I don't know, decent. We need to tear it all down. So let's delete this piece. Immediately start working on that. We'll delete that as well. Piece. It thinks the directive is complete because there are no construction sites. But yeah, I think we're happy with it for now. I like checking in on these. They're so huge. Okay, so let's, here's what I'm gonna do. I'm gonna blow up a couple of these so they're out of the way. And I am actually going to create like an obstacle course of sorts. So notice how, ooh, and maybe we should even, yeah, I like that. So we've created a very like frustrating and complex obstacle course here. We could even like, how do I clear it? I'm thinking maybe I even go crazier. Yeah, so like it doesn't make sense to build this direction normally, based like solely on need alignment. Oh, no. What I need to do, I know what to do. Here is our obstacle course. So if I scroll over, notice how the distance this direction is pretty close, but the distance this direction is way bad. Let me fill that in a bit. It's kind of fun. Okay. So, I like that. Let's go ahead and build those buffers. So this is all saved. I think that's in my history. Yeah, here we go. I'm gonna run this. And yes, I think that has placed everything where we expected. So this is really pretty close. This is probably equidistant with this, right? And then this is definitely closer than this direction. So that's cool. Let's maybe try just one more like test case. I'm gonna delete this. It'll think the directive is over. Yeah, but now I should. Let's see. I kind of want to see it. I want this to be an option, but it should choose this one. Okay, so if we do that, build buffers. Oh, and we didn't delete that one. So, okay, the previous one should complete now. There we go. And then we'll queue up the next one, which will take another 10 ticks, but that's fine. There we go. Oh yeah, and that was a valid move, so cool. That is definitely closer than that. Cool. Yeah, I think we have our algorithm for placing buffers. Actually, let's do one more test. The thing I want to try is if there are no valid neat locations, then it should still come up with something. Right, so that's gone. That's gone, that's gone, that's gone. Yeah. Yeah. So one there, one there. Those both look like the closest. That's perfect. Sweet. Okay. I like this. So at this point, we've implemented our build extensions and build buffers. I think we can add this in. But like this guy already works. You know, that's already executing. So we just add this in. We now have advanced requirements for a room. Save that. That one's a little bit harder to like type in the command line, but yeah, maybe we should go ahead and do it. So that should look like this. So now we should be able to see this. Yep, and then it's queued up. So now I'm going to go ahead and delete these two, and it should consider that directive complete. Delete that. Delete that. There we go. I believe it's this. So it's the simple ones. Now it's applied that directive. So if I run this again, we've got a repair in the manager. Perfect. I'm noticing that there are two upgraders here, but there's only one here. So let's go ahead and add one at the very end. Cool. Things are taking shape. We know we want this. And as a matter of fact, we want it on 5, we want it on 6, and we want it on 7 and 8. Add some commas. And that is all applied now. So I should actually watch this. I can just go crazy a little bit. Like, I'm going to increase the level. And it'll pick that up and plan a bunch of extensions. There they are. Good, and they all look as close as possible to this. And now let's go up to level 4. Boom. And the new did that apply a bunch of new ones? I think it did. Okay, so they go here and here. I'm gonna click it again, and I think we should see more even expanded past that. We increase that. I think yeah, this one's new, right? Click it again. Wait. Oh. Yeah, I think, yeah, we've like queued up stuff. Am I thinking about this the right way? 6 is that, 7 is that, 8 is that. So we have indeed queued up a bunch of stuff. That's not gonna work. I think I've kind of scrambled this up now. Whoops. But if I like delete all this stuff, then it's gonna be like, here, we'll go like all the way up to 7, whatever. If I delete all of these, so there are no more construction sites. Boom. Okay, so now that directive should be complete. We should pick up the one behind it. And we're on level 7, so there should be like a ton of these now. Wait another 10 ticks. Yeah. Check that out. Cool. So we've got this whole wild checkerboard pattern. Packed in really efficiently, but it's still easy to move through them. And it preserves that like town square spot so we can build everything. Cool. I am very happy about that. All right. Well, yeah, I think this is a good breaking point for today. We did some fun stuff. Next time, I'm going to try posting on the Screeps Discord. I know they have a Discord, and it might be cool to get some folks from there on. Assuming that's like kosher to, you know, do a little bit of like shameless plugging, like self-promotion. So I will look into that and double check. But yeah, should be fun. We'll get some people together. Yeah, thanks for checking out the stream. Or if you're watching in the future, then thank you for doing that as well. And yeah, I'm Andrew. This is Code Gets Creative. See you next time.